Delaware State University is involved in an exciting program conducting experiments in space. Here to talk more about that is Dr. Matthew Bobrowsky, who is the Director of Special Programs at the College of Mathematics, Natural Sciences, and Technology at Delaware State University. First of all, so these experiments are going to happen inside the space station.
That's correct.
And there's several around the country, I guess a couple dozen?
About 20 schools are involved in this program right now, and Delaware State is one of them.
How did Delaware State get chosen?
We actually applied to be part of the program, and we were selected to be part of the program by a couple of, well, there was an organization called the National Center for Space Science. I'm getting it wrong, sorry.
That's okay.
The National Center for Earth and Space Science Education, which oversees the program nationwide, and we applied to them and were accepted to have an experiment fly on the International Space Station.
Wow, it's quite a credit to Delaware State University and the science program there. So one experiment will be selected, and you had a competition. I guess the competition is still going on to decide what experiment will go up in space.
Right, it's in the final stages right now. So a number of student teams competed to design experiments and write proposals that would be persuasive in convincing a panel of scientists that it's worth doing on the International Space Station.
So before we get to the experiments,
yes,
why is it important at all to do an experiment on the space station? I know it has something to do with zero gravity, but why is that important?
Well, there are things you can do in zero gravity that you cannot do on the ground, normal Earth gravity. One is that you can create materials such as growing crystals or create pharmaceuticals that can be produced more effectively in a zero gravity environment than they can on the ground. In addition, if we are interested in long-term space flight, we might want to know, what can we do about growing food for astronauts, and how will materials behave differently? Biological materials, chemical materials, any kind of process could work differently in zero gravity than it does on the ground.
And the idea is if you find out it would work better, then you do it there.
That's right.
They would all move up there and you do it there. What are the finalists right now? This is pretty exciting. What are the ones that have a shot at going up there?
So we have 3 finalists that have been selected right now. One of them is an experiment on growing rice in zero gravity, and another one is somewhat related, looking at the direction of seed growth in microgravity. On the ground, plants grow opposite direction of gravity. The roots go down, the plant grows up. Well, what do plants do? How do they grow in a zero gravity environment where they don't have that cue from the gravitational force? So that's the second one. And then the third one was, does zero gravity have an effect on the drug tolerance of the bacteria Streptococcus pyogenes, which is one of the bacteria that causes the strep throat infection.
That's nice. I know, being a good science professor, you brought an experiment to show us, to show and tell. What exactly are you going to show us with this apparatus?
So what I want to show is that really the reason why you have zero gravity in the International Space Station. The International Space Station is not very far from the Earth. If you could stand on a high mountain that was that high, it's a few hundred miles up, and stand on a scale, you'd weigh maybe 90% of what you do here on the ground, at sea level.
Right.
Okay, so why are astronauts weightless? Why do they float around? And the answer is because they are in free fall. As the space station orbits the Earth, it is essentially falling, and when you are in free fall, gravity disappears.
So you're going to show us with this?
Yeah, I am. So we have a magnet and a little metal plate that gets attracted to the magnet, but I'm going to put it on this little shelf here. And right now, it's not getting attracted to the magnet. Why not? Because gravity is holding it down. But if we could somehow make gravity disappear, then the magnetic force would be the only thing influencing the metal plate, and then we'd get pulled up. So I'm going to now drop it and catch it, and so what we expect to see is that gravity will disappear, and therefore the magnetic force will then be able to pull the metal plate up. Okay, I'll do this on the count of 3. 1, 2, 3. And did you see that go up?
Yeah, that's fascinating. And I'm not sure we're going to have time for a long explanation, but I am fascinated by the fact that the space station is in free fall. I don't think people would think of it that way.
Well, one way you can see that is that if you look at, here's the Earth, say.
Okay.
Suppose you were on top of a high mountain. Okay, there's a high mountain. This is not to scale. You throw a stone off the top of the mountain, it goes kerplunk, right? Throw it a little harder, it goes a little farther before hitting the Earth. Maybe you can shoot it, a bullet out of a gun, and it goes even farther.
But it eventually comes down.
Well, maybe. The faster you shoot it, the farther it goes. And now if you get your super duper cannon and shoot it really hard, it'll go all the way around, and then you have to duck.
And it'll stay up.
But the point is, as it's falling, the surface of the Earth is curving away just as fast. So it never actually hits the Earth, even though it's still falling, just like it was in these first cases.
With that drawing, does that make us believe the International Space Station's eventually going to come down?
No, the International Space Station is in an orbit like this, where it never hits the Earth. So it just stays continually falling around the Earth, essentially.
I'm still confused. I got to take your class. Good luck. Please come back when one of the experiments is chosen to go up. Would love to hear more about it, and would love to bring the students in too, so we could talk to them about it as well.
Absolutely.
Dr. Matthew Bobrowsky, Director of Special Programs at the College of Mathematics, Natural Sciences and Technology at Delaware State University. When we come back, another student competition that has nothing to do with space. This has to do with the environment. We'll talk about that when the Delaware Way continues.